Students, now we are going to start with our third topic, that is sheet metal forming or sheet metal cutting operation. So what is sheet metal cutting operation? So it is, in simple manner you can say, the various operation which are carried on the sheet by using the punch and die combination as a tool or equipment in the cutting. It is known as the sheet metal operation. Okay, so this sheet metal operation is nothing but the press working. This press working has been defined as a chipless manufacturing process. So here we are not going to remove the material in the form of chip. Here we are going to shear the material, or we are going to cut the material. Okay, so that's why it is the chipless manufacturing. Now, by which the various components are made, as now I already told you. So components are made by using the sheet. So the press working operations are carried out with the help of metal forming machines, which are known as the press. The equipments or machine which is used to do this operation are known as the presses. So which shears or forms the component by applying the force. So force is required here. So if you look at the forming process, so forming process, the stresses induced in the material are actually the more than the yield stress, but less than the ultimate strength of the material, so that there is yielding, and after that yielding you are having the forming operation. Here we are not having the stress induced in this zone, but we are inducing the stress in the material, the above shear strength of the material, or above ultimate shear strength of the material. When the stresses go beyond that, the cutting will occur or shearing will take place. Okay, so in sheet metal operation, the stresses induced are greater than the ultimate strength of the material. That's why the shearing is very important here. Understood? So that's why the force we are applying here, force to shear the material or induce the stresses beyond the ultimate shear strength of the material. The main feature of the press includes the frame which supports the ram or a slide, then a bed, and a source of power with the mechanism for operating the ram in line or at right angle to the bed. So these are the main features of the presses, which are having the frame to support the ram, then we are having the bed, the source of power with the mechanism for operating the ram. So we are going to see these all things in the diagram. Okay, then the ram is equipped with the punch or a set of punches which have a shape of the job to be produced, while a die block is attached to the bed. So we are having here the punch and die combination, please remember. So punch is of shape that you are going to produce into the sheet. Say you are going to produce a hole in a given sheet, then the punch cross section will be circular. If you want to produce a hole with a shape as triangular, then the cross section of the punch will be triangular, like that. Then here punch is the male part and the die is the female part. So, and the die is always larger in size than the punch by the amount of clearance. Okay, so here the die is placed on the die block which is attached to the bed. Here the workpieces are produced or formed as the punch descends into the die block. Whenever the punch is moving or get descend into the die block, we are going to get the part to be cut. When this processor sheet metal components find extensive industrial and household applications, such as manufacturing of automobile, then aircraft bodies, So it is very important application of this press working or sheet metal operation in the automobile aircraft bodies. So many all the car bodies, see all the car bodies, the sheet which is used as a car body material are getting produced by this sheet metal working, and also the bodies of the aircraft are produced by this sheet metal operation. Then we are having the office appliances, kitchenwares. For example, in kitchenware we are having the kitchen well basin which is produced by the sheet metal operation, then storage cabinets, furniture items, mechanical toys, etc. The press tool operation of the sheet metal is by far the cheapest and fastest method of complete manufacturing of components. Okay, it is very fast process. So as the punch descend into die, it is a very fast process, and the operation is get completed. So what are the advantages of press working operation? So we are having the high productivity, that is faster making rate, better accuracy, uniformity of parts produced. So why uniformity? Because every time the punch and die combination we are using here, and the equal amount of forces are applying on the material, so we are getting the uniformity of the parts. Then possibility of using laser skill labor also. So there is no the complex or crucial shapes. Even the complex or crucial shapes are there, that shape are already is on the punch and on the die. So here there is less operator skill required for the operation. Then the low scraps, we are having low losses in the scraps. So predictable strength characteristics of the component, reduction in the weight, considerable cost reduction. We can have the automation. So these are the advantages of this operations, sheet metal operation. Now in the sheet metal operation, we are having the cutting operations and forming operations. So let us see the cutting operations in the sheet metal. Okay. So here the workpiece is stressed beyond the ultimate shear strength and cut off into the pieces by shearing action, as I already told you. The stress involved in the process are shearing stress. The common cutting operation using a die and punches include the following. Which are the common cutting operations we are having in the sheet metal operation as a cutting operations? We are having blanking operation, punching or piercing, trimming operation, shaving operation, notching, lancing, nibbling, perforating, parting, and shearing. So let us see the blanking operation. What is blanking operation? So in the sheet metal operation, when the produced blank or a disc by using the punch and die combination is useful one. The produced slug or produced blank or produced disc is useful one to us. Then the operation is known as the blanking operation. Okay, see blanking is what? Blanking is the operation of cutting out the flat intermediate shapes called as blanks, which are to be further processed to produce desired shape. So see that the word blank is very important, or you can say it is as a disc or slug, and that will be subject to the next processes or desired uh, processes to make the part. So blank is very important here. We are producing the blank, and that is useful for us. Okay, the sheet metal from which the blank is to be cut is properly located over the die and punch lowered into the to produce the required cut. So we are locating the sheet properly onto the die, and the punch is lower down to get this blank. So neglecting the small amount of spring back that occurs when the shearing force is removed, the size of the hole made in the sheet is the size of the punch, while cut out piece has a size equal to the die. Now see, the spring back is what? That is spring back is nothing but the elastic recovery. Okay, so so to neglect the small amount of this spring back which are going to occur when the shearing force is removed, because every material having this tendency to come back to its uh, regain its original shape. So that's why here the size of the hole made in the sheet is the size of the punch. Okay, and the size of the punch while cut out the piece has a size equal to the die opening. So basically here, please remember the simplest way I'm saying, the in blanking operation, the size of the die is equal to size of the blank that you need or that you want, and in punching operation, the size of the punch is exactly equal to the size of the hole that you are going to produce in the given sheet. You are not bothering about how much size or what is the accuracy of blank that is going to produce from it, but you are more concentrating on the hole that is produced. In blanking operation, we are concentrating on the disk that is produced. We are not bothering about the hole. Okay, so that disk is subsequently is going to have the next operations to make the part. Understood? See here, this is a blanking setup. This is the punch holder. This is the bolster place, which is actually based on the bed. On that we are having this die block. Okay, this is actual die, and die is held in the die block. So we can see here, this is the punch and this is the die. This is die, this is the punch. So this is the stripper plates. Each and every element of this press we are going to see in details, but just see here, when this punch is descend into the die, this blank or this sheet is going to shear. It is shearing, and see here the cutoff sheet or cutoff blank we are getting. So the operation where this blank is important for us, we are not bothering about the whole produce in this strip or the sheet. Okay, then the operation known as blank. And when this, we are not bothering about this sheet or cutoff blank or disk, we are bothering about this whole produced here. That is a punching operation. Understood? See, now punching. The punching or piercing is similar to the blanking, except that the metal piece cut out in piercing are scrap. So here we are not interested in these disc or the blank. We are interested where? We are interested in the whole produce, isn't it? So this is scrap for us. This produced a blank is scrap for us, but here the produced hole is useful one for us in punching operation. So here the size of the punch used is a piercing equal to the required size of the hole, while the die opening is made larger by twice the desired clearance between the punch and die, as I already told you. So here in punching operation, the punch is made to the exact size of that hole, whereas in blanking operation, the die is exact equal size of that disc or sheet or blank that you are producing. Now basically the die is always larger than the punch, whereas, or we can say, punch is always smaller than the die. By how much amount? By the amount of clearance. So clearance is very important. We will see in the mechanics of sheet metal operation where the importance of clearance I will mention to you. So here, see here, the die is always larger than the punch, and punch is always smaller than the die by the amount of clearance between the punch and die. Okay, so why it's twice here? So it is radial clearance, then it is taken as a two times, or diameter clearance, it is taken as one time. Okay, now see here, this is a blanking operation, and this is the piercing operation I have shown here with the uh, shear. See here, this is the blanking operation. You can see I have provided the shear. Okay, the die is make incline or taper at some angle. Okay, this is the shear, and if you look at here the punch is given with the shear here. So you can see here in blanking operation, the shear is provided on a die, whereas in punching or piercing operation, the shear is provided on punch. Please remember this. Now, if you look at the clearance in blanking operation, the clearance is provided on the punch and die is made to the exact size that of the size of the blank. In punching operation, the clearance is provided on the die, whereas punch is made to the exact size that the size of the hole. The third cutting operation is a trimming. So trimming is the process of removing the excess material or extra material which remains around the parting line after operation like casting, forging, and sheet metal drawing. So trimming is done by forcing the parts to be trimmed through a trimming dies with a suitable punch. The operation is similar to the branching operation. The press used for trimming normally have the larger bolster plate area compared to those of used for blank. So the difference here is that we are having the larger bolster plate area than the blanking die. We will see the diagram, we will come to know what is bolster plate and all. Next, shaving operation. So shaving is also similar to the trimming except that the amount of metal removed is much less, around 10% of the metal thickness. So very less material is uh, removed in the shaving operation. So shaving is done on the blanked or pierced workpiece to obtain the smooth square edges with the closer dimensional tolerances. So this is actually after cutting operation. So which is simply going to give us the accuracy of the uh, drawn product from this sheet metal. Okay, so it will create the smooth the square edges with the closer dimensions. So shaving dies use much lower clearance than the blanking or punching dies. So what is the you can say one of the property of the shaving die, that is they are having a very lower amount of clearance than punching and blanking dies. Next cutting operation, you can say notching operation is what? So is the operation of making indentations at the edges of the workpiece as shown in this figure. See, you can cut the sheet on the edges, any shape. So this is a notching operation. A die and punch of suitable shapes are used to make these notches. Okay, any shape of notch you can make here. That is a notching operation on the edge of the sheet. In lancing operation, that is production of incomplete hole at the center, and you can bend that one side of the cut apart. See, incomplete hole is not complete hole that we are produced in the sheet, and it is partially cut in a sheet, and the cut metal, see the cut metal have bent on one side. See here, that is a lancing operation. If you can see, the nibbling operation is what? Nibbling operation is nothing but the production of one big hole by using the uh, many holes. One big hole can be produced by many small holes. By these small holes can be produced by using the punches. Okay, these punches may be the circular or triangular cross section. That is a nibbling process. So nibbling is the process of cutting irregular shapes from sheet metal without using a die and punch of the corresponding shape. As I told you, no exact punch or die combination used. We are having the small punches, and by using that small punches, we are creating the big hole required shape and size. So when number of pieces of a given shape to be produced are small and the possibility of repeat production run is remote, it becomes very uneconomical to use dies and punches of corresponding shapes. So such as jobs are handled on a nibbler, which uses a small round or triangular punches that reciprocates vertically in and out of a corresponding die, producing a series of overlapping holes. As I told you, number of holes, small punches. Suppose this is the size of a hole, then if I am small punches, then I will go on producing these small holes, and with these small holes which has overlapping or one another, producing this entire. The sheet metal is guided through the machines along the path desired. The process is slow and cut edge may need to further finished, but it eliminates the need of costly special dies. So this is the nibbler. See, this is a one small punch, and we are go on making the holes. We want actually this shape. Okay, this shape. So small punches we are overlapping the small holes one over another and producing this shape. That is the nibbling operation. Perforating operation is nothing but the production of many small holes in a given sheet. That is known as perforating operation. Parting of operation is what? So parting is operation is which cut simultaneously along two parallel lines or contours in such a way that the side thrust is neutralized. So simply parting of operation is producing the two halves of the sheet, you can see. Then the shearing. So shearing is a general purpose shearing operation along a straight line, mostly for cutting small pieces from a large sheet stock. So we are having large sheet stock, from that we want a small pieces. So general purpose shearing operation uses straight line shearing for cutting, and the machines used for the purpose can be divided into the square shear or the rotary shear. So the next cutting operation is the shearing operation. So it is generally the straight line cutting operation where the material is sheared or cut mostly uh, along the straight line, and which is used for cutting the small pieces from the large sheet stock. So as I said, general purpose shearing operation use the straight line shearing for the cutting operation. And here the machines are getting divided into two types. One is square shear. See here, this is a diagram for a square shear. So here the workpiece, this is the workpiece, is getting sheared between the two blades. One blade is fixed to the machine and another blade is moving up and down with the ram of machine. This is the square machine, square shearing. Okay, and in rotary shearing, this is another type of shearing. So here there are rotating disc blades. There are rotating disc blades. One is lower disc and another is upper disc blade, which is shearing the material. And the important thing is that the forces involved in this operation in rotary shearing are lower in this case than the square shearing, and the length of the sheet does not possess any problem. So however the length of the sheet, there is no any issue. We are having a very good cutting or shearing operation, and with the lesser force than the square shearing. Thank you.